Have you ever wondered what secret sauce stops your favorite apps from completely crashing under pressure? Well, today we are diving deep into a piece of invisible architecture that basically makes our entire digital world work. Let's get right into it. Okay, just picture this for a second. It's peak time. Millions of us are all tapping on our phones at the exact same moment. We're ordering dinner, we're hailing a ride across town, maybe we're grabbing a flash deal on some huge e-commerce site. I mean, you'd think that would cause a complete and total system meltdown, right? But it doesn't. And the really elegant solution to all of this potential chaos? It's a simple but incredibly powerful piece of tech called a message queue. So, what is it exactly? Well, you can think of a message queue as kind of like a post office for software. Instead of different parts of an application trying to talk directly to each other, which, let's be honest, can get super messy, one service just drops off a message into the queue, and another service picks it up whenever it's ready and has the capacity to deal with it. What this really does is create a buffer, a sort of digital waiting room that keeps all that communication organized. It makes sure nothing gets lost and that the system never, ever gets overwhelmed. And this one simple concept has some seriously powerful implications. To really get this, let's make it concrete with an analogy I think we can all relate to: a super busy fast food joint. Okay, check out how perfectly this maps. Your order, that's the message. It doesn't go straight to a cook. Instead, it just pops up on one of those digital screens. That screen is the message queue, organizing all the requests as they come in. Then a cook, whenever they're free, just pulls the next order off the top. See? The customer and the cook never even speak directly. The queue manages the entire workflow, keeping everything efficient and totally orderly. So that restaurant system is pretty efficient, right? But in the software world, this exact model unlocks what I like to call 4 distinct superpowers. First up, you get decoupling. This just means the sender and the receiver don't have to be active at the same time, which makes the whole system way more resilient. Second, scalability. If you get a huge spike in orders, you just add more cooks or more processing power to clear that queue faster. Third, and this is a big one, reliability. If a component fails, the message just waits safely in the queue until that component is back online. No data's lost. And finally, asynchronous processing. The front end of the app can keep taking new orders without having to wait for the previous ones to be finished. It makes for a much, much smoother user experience. Okay, this all sounds great in theory, but where do we actually see this stuff in action? The short answer, pretty much everywhere. Let's look at some of the apps you probably use every single day. When you click that Buy Now button on a site like Amazon, you're not just buying something, you're creating a message. That message gets placed in a queue, and from there, different services pick it up. One processes your payment, another updates the inventory, and a third one tells the warehouse to get your package ready. It's a perfect example of decoupling in action. Or think about Uber. When you request a ride, that's a message. It goes into a queue to be matched with available drivers. But at the same time, all the GPS updates, those arrival time notifications, trip status changes, those are all being handled as separate messages too, making sure your app stays perfectly in sync without totally overwhelming the system. Now, this is absolutely critical. When you make a bank transfer, that transaction is queued up. This guarantees, and this is so important, that even if a system has a little hiccup and goes down, your transaction will just wait safely in line and will be processed exactly once. It's the key to reliability when we're talking about your money. And what about the sheer volume of stuff happening on a platform like Twitter? Every single like, every comment, every notification, you guessed it, it's a message. Queues are absolutely essential for handling this massive, constant fire hose of information and making sure your feed updates smoothly without you ever seeing the chaos happening behind the scenes. Of course, not all queues are created equal. You've got different tools for different jobs. There are the classics, like Microsoft's MSMQ, which is deeply baked into the Windows world. Then you've got something like RabbitMQ, which is a super popular, versatile workhorse for tons of web applications. And then, when you need to handle a true tidal wave of data, like tracking every single click on a massive website in real time, you turn to giants like Apache Kafka, which is built for that incredible, mind-boggling scale. But, as powerful as message queues are, they aren't some kind of magic bullet. Like any big architectural choice, actually implementing them comes with a whole set of pros and cons that developers have to really think about. It's really a classic engineering trade-off. On the one hand, you gain this incredible reliability and scalability. But on the flip side, you're adding another moving part to your system. And that introduces a bit more complexity.
It requires careful monitoring, and sometimes it can add a tiny bit of delay or latency to the process.
So if there's just one thing you take away from all this, let it be this. A message queue is basically an organized and very patient middleman. It sits between different parts of a system, fielding requests and handing them off in an orderly way. And that simple act of organization is what makes the applications we all rely on more reliable and ultimately massively scalable. So we've seen what they are and why they are so incredibly important. But that just brings us to the next big question. With all these options out there, like RabbitMQ and Kafka, how in the world do you decide which one is the right one for your specific project? Well, that is a whole deep topic on its own, and it's one we'll be tackling in our next explainer.